Hi there, I'm Alim Ul Karim. Today on behalf of Tech Forum, I'm going to talk about object-oriented programming. If you're already from an object-oriented background, then this talk may bore you because this is going to be very detailed and mostly for beginner to advanced level. So if you have never done any object-oriented programming before or have few knowledge, then this is the session that might help you object-oriented programming for the rest of your life. Finally, I can promise you that this is going to be the best object-oriented programming video that you ever going to find on internet. I'm from Developers Organism. We make products for developers, not only for users. Currently, our website is under construction. However, we're not really interested in our website right now, but we are interested in our products. Presently, we're doing a big project called Developers Blog, which is going to be an open source free CMS system in C#.NET. Well, you might ask why. Even though there are a lot of solutions already exist in the market, the challenge is to make the better product than all the existent one. And we're analyzing for 3 months and we already have a great team. We're going to make a product which is far ahead than all the existing product right now. So if you really want to join us, you can do that. This is the email address that if you really want to join, you can mail us and we will be really happy to see you on board. So prerequisites, I'm assuming that you already have basic C# programming skills in addition with namespace and function concept. Don't freak out if you don't know UML because we're going to talk about it. It's a very simple concept, but it's really a prerequisite, but we're going to go with examples so that you understand what UML is. We're going to cover these following topics. Some of those are in details and some of those are in brief. And complex ones are going to be very detailed and easy ones are going to be in brief. You may have heard from your colleagues, friends, or read an article about object-oriented programming or OOP. Then you have Google and end up here. In the previous days, when I teach object-oriented programming, I give people example that it's a formalities and it's kind of a ritual that you should follow. But turns out it's not a ritual, it's kind of a required thing to do the programming. 7 years ago, I wrote a program for a company which was very good at the time, and the little object-oriented programming I know, I just skipped. And turns out after 7 years later, not 7 years, few years later, when they came to me for some change and I was really freaked out. That crap I wrote, and technically the changes were for changes that I have to make was really very simple, and technically it was really 2 hours work, but the system was so devastating and so inflexible, I have to spend 1 week to solve the problem. So you can get my point that if you don't use object-oriented programming, your system will become inflexible. And we're going to talk about in details that some of the times overdoing object-oriented programming also make your system inflexible. When people talk about object-oriented programming, they really meant 5 things. And first, they meant class. Second, object. Third, inheritance and encapsulation. And finally, polymorphism. It's not that these are the 5 things that only exist. There are many things, but these are the 5 things that people really understand. Object-oriented programming history began around 1960s when MIT tried to develop a robot with object-oriented design. From that concept, the procedural programming changes into object-oriented programming. So let's see our concepts in detail. In high school, I never took biology, but turns out that somehow biology contributed into computer science, and the class concept first came from biology. The purpose of the class is to organize your code. Class is an abstract representation or an blueprint of an object. Let's say you have a person class. A class says a person should have a first name or last name, but it does not say what the first name would be or what the last name should be. Something like that. It's just abstract. In simple words, a class is a collection of methods and properties. A class should have two layers. One is data and another is logic. And data layer is also known as attributes or properties, and the logic also known as functions, methods, or behaviors. So let's see UML. We have talked about UML that you should have known this, but it's really very simple. I don't really think that you should have to Google. Just make a box and write the name of the class on top of the UML. Let's say it's a person class, then you should write the person top of the box, and then in the first half you should write the properties or the data or the attributes of the person, and in the second half you're going to write the methods, behavior, functions of the person class. UML is really represent a class in short. That's it. So let's see a UML of a person class. Let's say this is a person, and a person should have a first name, last name, date of birth, address, gender, and these are data or attributes or properties. And the second half will contain the behaviors or functions or methods. Whatever you say is correct. Behavior, logic, methods, or functions. So let's say you have a calculator application and you really want to use the classes. So what you can do is make separation of your logics and into separate classes. Let's say you have basic functionality of the class, so you put those basic functionality in the basic calculation class. And you have scientific calculation part, you put those into scientific calculation class. And this way you can organize your code. This is the purpose of the class. So what is object? So a class is an abstract representation like this, and the object is like the house itself, building on that blueprint or the abstraction. So if you assume that this is the blueprint of the house, which is the class, the object is making the house on top of that blueprint. So a person, let's say the person class we have here, when we create the person class equals new, the new creates the person class, and this new instantiate the person object into this person, smaller case person. So this is the object and this is the class. That's it. And this is the data type that we are picking up. So you have seen the object. So this is the object creation. So how you can set a property or change the properties in a class, it's very simple. After creation of the object, write the object and put a dot, and you'll see the properties of that object. In this case we have first name, last name. So I just dot the person, and then I got the first name, and then I'm putting value alias. And this is how you set values. And last name Roman San, this is how I set values. And how you get the values, it's very simple. It's like setting the values, but taking it in another variable. That's how you get the variable. That's it. Now let's see some coding. before taking our hands on coding, you should have to know a few things about class. Anything you write in the class is known as the members of the class. So whatever you write inside the class is the member of the class. In addition, by default, all the members in the class are private. That means if you don't define any access modifier, we're not really going deep into the access modifier right now, but try to remember that. It will help you to cope with other lessons later on, that when you do not write any access modifier, it assumes that a member inside a class is private. And the private is the most restricted modifier, access modifier, and private do not let you access any members inside the class unless it has any other modifier. So if you do not declare any modifier before any member, that means you cannot access that member outside of the class. And any member inside the class you can access by its name, or you could write this, and that would be the explicit way to call a member inside a class. This and the member name, this dot and then the member name. So let's say you have a property or a field, let's say first name. To access that, you could write inside a method first name, and then you have the property. But you can also write these dot first name. These are the same thing. So it also solves a problem when you have a parameter as a first name, same as your member in the class. To differentiate those, you can use this. When you say this, it will explicitly mean that you are meaning, or you are trying to access a member inside the class. And when you don't write the this, it means you are trying to access the parameter. So this is the things that you should know before moving on to the coding. So let's dive in. This is a pretty simple console application, and we have another project attached to it. It is an empty project, class library project. So in this project, we have a basic console application and another class called person. The person that we have seen in the slides is defined here. It's very simple. Write the fields. We have written the fields, public fields. These are known as fields, and this is public modifier. We're going to talk about access modifiers later, but for now just understand that public means that everyone can access it. That's it. So we really put those fields to public access modifier, so everyone can access it. And we have two methods. In the slides you have seen many behaviors, but we only write two methods. That's it for simplification. So that's our class. So how to write a class? Let me write it again so that you can understand. Write class and the class name. In this case, person maybe 2 is a person class. And let's write the properties, public, and in this case these are the fields, not properties. Don't confuse the properties with fields. Try to remember that these are the properties. We're going to talk about these are the fields, and we're going to talk about the properties later on. So string, first name, let's say, just, and to write a method, what, and define the method. That's it. So that's how you're going to create a class. This is it. So a class should be, one class should be in one class file, but you can write multiple class in one CS file, but it's not really recommended. The best practice is to put your other classes or interfaces into separate files. This way you could find your classes very easily, and the best way is to keep your class name as your C# file name. So in this case the C# file name is person, so I write my class name is person. If you go to the program, this has a class name of program like this. So this is the best convention, but you could write whatever you want. It will not complain and it will run just fine. So that's it. So we have seen the class. Let's see an instantiation of the class. So person, you could write anything. You don't have to write only the person, but for simplification I'm just writing the object name as person. That's it. And new, like this. So to change the first name, I just go to the first name and say that first name is Elias. That's it. For now, that's it. And let's say that I tell my person to walk, and let's see what's happening. Elias is walking. That's it. It happens like this because I have a console.writeLine method in the walk method. As you can see, it's very simple, nothing complex here. So that's how you instantiate an object from a class, and then you manipulate the object by accessing the properties or calling a method. To call a method, you whenever you see in a programming language, in most popular programming language, this parentheses is, you have to understand that this is a method. So it's a method, logic, or behavior, what we have discussed earlier. So that's it. And let's go to our slides now. So let's see a class constructor, because a class, when a class is created, the constructor is the first method that is invoked. A class could have 0 or multiple constructor. Even though a class doesn't have a constructor, it will call the constructor implicitly. So constructor is always called. Whenever you call new, then person, the constructor is implicitly called, even though there is no constructor. When you write a constructor, it is explicitly called. So let's see some examples of constructor encoding. So here I am in the Visual Studio. We are going to the person class. To write the constructor, what you can do is write a public and then write the same name as your class name. That's your constructor. The exact name as your class name. That's your constructor. So you can have 0 or multiple constructor. We're going to talk about multiple constructor later, but you can have multiple constructor by overloading method. We're not going to talk about overloading right now. We're going to talk about overloading later. So when we talk about overloading, you'll understand that how you can create multiple constructors. And you could do something like this. You are initiating, let's say, an array or something like that. Whatever this type of object you do, work you do, you can do it in the constructor section. So let's just go very simple and write line that a person is created. Person is created with name. Let's see that what happens to the name. So first name, that's it. So let's run the code. We don't need any change in our code. So whenever we call the person, the person is created method is executed, but the person name is really empty, so it really doesn't show anything. You really go to the code, it's really empty string, null string, so it doesn't show anything. So it only shows those two console write lines because this was the first one executed and the next executed when the walk method is called. That's it. It's very simple, not complicated. So another thing about the constructor, in Visual Studio you could write constructor very easily. If you write ctor and hit tab, you will have your constructor. That's it. So let's just delete those lines because we are not really interested in the constructor of a person right now. Let's go to our slides. So let's see how to create a destructor. A destructor is used to clean up your memory or to make your application more efficient. But luckily for C#, if you have any memory leaks or memory problems, the garbage collector will kicks in time to time and clean up your memory. You really don't have to do this, but sometimes it's really a good practice to use the destructor. And when you have a huge list of items, it's really a good practice to remove it in the destructor. So let's see how to create a destructor in a class. So let me switch over to Visual Studio. Here I'm in the Visual Studio. We could go to our person class, and I have separated my person class with those regions. I really like to separate my codes and like to use the regions, and you could separate your codes like regions. I will show you. You could do it by Control K and then S. Then you go to Visual Studio and go to region, and then I'm going to say that destructor, because you can have only one or zero destructor. To write a destructor, you have to put the tilde sign. I call it tilde sign. I really don't know that what it's called, but really remember that it's really called the tilde sign. So whatever it is, put this and then write your class name, and that's it. That's your destructor. So if you have a huge list, you should clean up your list, but for now we're going to just print out that destructor is called. That's it. So let's really run the program and let's see what happened. And I'm pretty sure the destructor will not be called. So or did I make mistake? Okay, so that's it. Destructor is not called. So destructor, why is not called? Because my person is not destroyed. So let's really destroy it by setting it to null, because it doesn't have any memory reference to it. So a garbage collector will kicks in and destroy it at some point, and this is when the classes destructor will be called. But for C#, if we run this, you will not see this happen right away. To do this happen right away, what you can do is call the garbage collector, write GC is the garbage collector, and say collect. That's it. And now if I run my code, I'll see that destructor is called. Now let's see some complex scenarios. Not really complex, just the simple scenarios, but now I'm going to go break some rules that I have said earlier, but that's just for the convenience of file for this demonstration, but it's not the right way to do the work that we have discussed earlier. And I have so many files in my project, and we're going to include one by one as we need those. So we're going to include the destructor class, and here I have introduced two classes in one file. It's just because that it's just a demo purpose, but on a professional project you shouldn't do that. So here I have a simple destructor class, and then I'm just going to comment out this portion because we are not there yet. We have really a list where we have created, we make a capacity of 2000. If you know the list objects, it already creates the 2000 elements or array in the memory heap. So, At the end of it, I'm going to set the list to null so that it wouldn't take any more memory at the heap. And then I'm calling the destructor. It will be same as before, but this time the method will be different, and we're really cleaning up something. It's not really very fancy, but let's just do it. Destructor class. Oh, let's see. So let's show you something else. Here we are doing the person, and then we're saying that the object name. So the first thing you define is your data type. So a person is a data type. Whenever you make a class, it's a data type, and a class's discrete name is data structure. So whenever you see that it is about data structure, you have to understand that it's about class, but in very detailed manner. That's it. So what you can do as a C# programming, write var. So you have to really understand the var. Var is like, I'm really too lazy to figure out the type. So what happens is, at the compile time, var is compiled to person. The person will be replaced into the var. You cannot write like p. That's it. If you compile it, you'll get an error. That's this. So let's just do it very quick. Yeah, that you cannot compile it because you're implicitly defining a thing, but you're not defining that what the thing would be. So it's really giving you an error. So at the compile time, the compiler doesn't know that what type it should put. So that's it for var. And there is also a dynamic data type, and let's really go over dynamic very quick because many people are confused with dynamic and var, and dynamic and var are not really two same things. Dynamic resolves at runtime and var resolves at compile time. So whatever happens here will be defined at compile time when I put the start command. And dynamic resolves when you need the object, or at the runtime when you call the object, it will resolve. Dynamic is weakly type. If you ever have any idea about weakly type, C# is the same type, strongly typed and weakly typed. So let's not go very deep into this because there are very deep conversations about these type of topics. Just go very simple and create our class. In this time I'm just going to go var. I'm not going to equals to new destructor class. That's it. Destructor. And then I'm going to set the destructor equals null, and if I run it again I will not see the destructor method is called. So if I run it, I'll see the capacity, but destructor method is not still called. So to do that, I will have to again call the garbage collector and see that destructor method is called, and the least was null at this moment. So I know that it is clean. So that's how you can use the destructor. Now let's quickly move over to our slides. Static modifiers. We're going to go very deep into this static modifier because the first time I learned it, I have to struggle a lot. So, and in my career I have seen many people who really doesn't get the static modifier very quickly. So we're going to go very slow and very detailed in this static modifier topic. Two things that you should remember: that static members can be accessed without instantiating the class, and static modifier members are load at first the application is run. So if you have a static variable or static object in your application, it will be shared across every user. That's the summary. So let's really dive into it. if you're marking a class as static, then you have to mark all the members as static. If you don't do that, you will face a compilation error. And if you have a static class, you cannot inherit it as well as create it. And static classes don't have any constructor or destructors. So what about the members? So public static members can be accessible by class name only from anywhere without instantiating the class. So you instantiate a class by new keyword so that you can access any public static member without instantiating the class and from anywhere by its name only. It's a very important concept, and we are going to go very deep into it. And if you have a private static member or only static member inside a class, then you can only access it from the static members only. That's the two concepts that you should remember for the members, and we're going to go very deep into it with examples. And let's see the next slide. Assume that this is Visual Studio, and I'm writing my statement, and let's see some code. Let's say that I have a class A and a method, public static method print, and I have a private non-static method that is foo. Now if I want to access the print method of that class A, I can write the class name directly, class A, and put a dot and then call the method, and it will run just fine. Let's say you have, or we have, another class B, and we have three places. One is public constructor, which is a public method assumed to be, and another is private method, and another is private static method. So if we want to access the public static method of that class A, what we can do is write the class name and dot and then call the method, and it will work just fine. So same is also true for anything method and the static anything method. And you could pause the video and go by line and try to understand, and if you have any problem, mail me. It is very simple, and if you have time, try to compile it in Visual Studio. You will get the correct result. So let's say you have a private static method or only static method which doesn't have any access modifier in front of it. So here is my private static method print, and I have a non-static method and a static method in my class. So let's say I want to access that private static method with my class name, and I can do that because it's not a public method. And if I try to access it by the this keyword, I will again fail because it is a non-static method, and you cannot call static method from a non-static method. And let's try it on the static method. If we do the these dot print, we'll be successful because we can call static methods or members from static members. And if we try to access again with class A dot print, it will not be succeeded. And let's see the example for class B, and for all the examples we will be failed because it is a private static member. We cannot access it outside the class. So that's it. It's a very simple example, and it really describes all of the static members abilities. So if you have any questions, mail me right away. I will really get back to you as soon as possible. So let's visualize that how static objects work, because that's really a very good programming skill that if you understand static, because it's sometimes very memory efficient and sometimes it's very memory inefficient. So if you're not careful, it is very memory inefficient. If you're careful, it's memory efficient. So let's see. Let's say you have a web app, and you have a class B as a static class in your web app. So before starting the app, maybe you just put it in the cloud, or maybe one user is trying to access it. The static B class will be created. That's it. That's the first thing it's going to happen. And then the web application will run and the other classes, and in this case I'm assuming that the web application only has class A. So this is a normal class, and this is created because user 1 requested something from the class A, but static class is created. If the user 1 needs it or doesn't need it, it doesn't matter. Since it's a static class, it will be created and shared across your application. Let's say user 2 comes in at the same time, and class A will be again created. It will be again created for user 2, but class B will not be created. It will be shared across. So let's say you have user 3, and it will be again class A will be created. So let's say that user 2 is gone, so class A will be gone, but static will still remain there. Let's say your user 2 again comes in, then class A will be again created specifically for user A, and these are all in other instance. Everyone are going to occupy memory for class A. Class A will be replicated 3 times for 3 users, but class B will be shared. Let's say user 2 is gone, so the class A for user 3 is gone, and so on. At last, when you have no user, or when you practically closed your application, your static members will go. That's it. Passing reference parameter is very interesting, and lots of people are failed to explain, and lots of newbies are really suffered from understanding this concept. So that's why it's not a functions session, but it's really about the function. And why I choose this topic, it will come up when I really finish talking about it. So I've seen that a lot of newbies suffer to understand passing parameters as a reference type or the value type. So MSDN says that the primitive types are passed as copied, or a value type. So value type means it's copied, and non-primitive types are passed as reference. So at this moment, if you don't know about this, you are really confused. So let me give you some light on this topic. And let's say that I have these functions. So I'm saying that this function is a non-reference type. So I'm choosing, explicitly choosing the string, because the MSDN says that the only the primitive types passed as a value, and non-primitive type, string is a non-primitive type. So primitive types are char, int, double, decimal, date, something like that. But if you go to primitive types, C# primitive, you'll see the long list. So other than that, all are non-primitive types. So string is a non-primitive type. So when you pass a string, it should be changed and give you the different result that you expect. So in this case, I'm just marking as static so that I could call it from the main function. That's it. Static doesn't play any role here. So let's see. I have x equals to hello world, assuming that it's Visual Studio. I'm just putting it in slides so that you could understand easily. So I print it, and it prints hello world. And let's say I pass my x to the change function, and these x and x are not same, if you know from the functions lesson. This is like in Bangladesh, and this is like in Maldives, something like that. So in 2 different places, and each of those doesn't know of each other. The only way they know by passing it to the function. These x and these x are not same. After passing this will be same or be linked. So MSDN says that when you pass the x, it passed as reference type. So if I passed it and I changed it, so reference type means when you change an object or change something, it will remain same for finishing that function. So the change should change the change string x, and after that it should print change. But if you run it in Visual Studio, it will give you that hello world. It will be still same. So when I see it at first time, I was really puzzled because they say that it's a reference type, and I couldn't really understand that how it's really happening. So when I asked a PhD guy, he was also failed to describe the fact that what is going under the hood. So what he says is that it's just immutable. Or when you see a type is immutable, it means it's a fixed type. But it really doesn't explain a lot. So we're going to go very deep into it. So next, what I'm doing, I'm passing my x to a change ref function, which is a reference type function. If you know from the ref keyword in Visual C#, so ref really does is change anything. If you pass an integer with the ref keyword, after that, if you modify the integer, you will have the modified integer after the function is executed. So after that, it really prints changed. But I shouldn't have to do that, because only for primitive types I should have to do this. But since it's not a primitive type, it should be passed as reference. So what's going wrong here? So let's see some of those in terms of memory. So string is a mutable type, which means it's a fixed type. So what happens is, whenever you create a string, it creates in a new memory location. It really doesn't change the previous string. Let's say you first time say hello world, and next time you're changing the hello world to change. So it never really changed the hello world. What it does, it looks up to the heap or memory and then assign a new location for changed and make a new string. That's why it's a fixed type. Every time you change it, it really makes a new string. It doesn't change the previous one. That's why it's a fixed type, or said to be immutable. So let's see in terms of memory that what happens. So when you say that string x equals hello world, it really creates a new string in the memory hello world. So when you call the console.write line, it really prints the hello world from that memory heap. So when you call change, so it really passes the reference of the location into the function here. After that, when we are doing change x equals change, so x equals change is really doing a new thing to a string. So it will create a new string to a new memory location, and let's say that new location is here and x is created here. But after the function is passed, it really remembers the previous memory reference location. That's it. So when it's print, it prints hello world, but it really changed in the process of the function, since that it creates into a new memory location, so you cannot see it. So when you pass it as reference, what does it? It also passes the memory location to your function reference string. But this time, when it changed to x, it also creates a new memory location creates a string changed to a new memory location, and when you get out of the function, what it does, it gives the reference of the location to your x. So whenever you write it, you will get the same result as changed. That's it. So what happens when we have primitive types? Let's say an int. So what will happen? So let's say we have an int of 51 and it creates a new memory location. It creates in a new memory location with 51. So when you print x, it prints that number, and when you pass it to change, it really copies the x to here. So how it does is it makes a new copy of your previous number or previous primitive type, whatever it is, maybe date or time or something like that. But when you changed it, it changed in that copied location. So when you get back, you really don't get back the location that you are pointing to previously. That's one. So you really don't get it. So you really print the 51, and if you really pass it to a reference type function, so what happens is this time it really passes the reference, and when you change it, you really change it here. And so when you print it, you'll get the 12 there. That's it. That's how reference types works. So if you really don't get it, mail me, I will try to help. The reason behind giving you this example is you can pass your class as a data type in a function parameter. So whenever you pass a class as a function parameter, what happens is it passes as a reference type. So you really don't, so that you don't confuse with the value type or reference type. That's why I explained it. So finally, this is the class pattern that you have seen so far. The third bracket means optional, that you can write it or don't write it. It's really up to you. And you haven't seen generics yet, but you'll see it very quick. And the format is you first write the access modifier, which is defined here. You can have only public or internal for the class, or nothing at all. If you don't have anything, it means internal class. So access modifier, then modifier. The modifier can be picked from this list. I don't know if there is any kind more, but you could experiment it. But so far what I have seen is these 4 types you can get in C#. So if you have another type, let me know, but it's not really important because all of those are not really helpful all the time. Few of those you're going to use all the time. And identifier is the name that you're going to put for your class, and you really can't have any combination from this list. And static, we have talked very detailed about it. You cannot create it as well as inherited the class. And sealed means that you cannot just inherit it. That's it. And partial, it's my favorite. It's really after .NET 4.0 maybe, or 3.5. I really don't remember, but I really asked this question in interview. So if you are interviewed by me, be prepared for this. So what partial does is if you have the classes in same namespace, at the compile time they're just merged. If you really go to MSDN, you'll see some excellent example. I have some in my demo projects. Let's see some examples. So we are in Visual Studio. Let's really switch over to this project. It's really an empty project, so I have few classes in there. This is the A class, which really have some properties, fields with some access modifiers. And this project is for checking access modifiers. When we'll get to it, we'll talk more detail about it. So we have a same class name as class A in a different directory, class A, but I really put the namespaces same. As you can see that the namespace is same as this. And if you see the slides, it says that partial classes only combine or merge if they're in the same namespace. So if I really include these files in my project, let's include the class C as well. So what should happen is in the compile time they should be in the same class. So in class A, in this different folder, I really have only one field what says that public int. It's a public, so it could be accessed from anywhere. So partial public field, that's it, so that you understand that the partial classes are merged. And I just put the partial keyword before the class, and here you don't see that there is a partial, but you still can put a partial, it doesn't matter. But there should be one class which shouldn't have partial, but I really don't think that compiler will mind if I really put this. Yeah, compiler doesn't mind, but the convention or the best thing to do is put your one class that doesn't have the partial in it. So partial means there is some other class which is same name as this. That's it. So in the compile time, those both classes should be merged, and Visual Studio is very smart. We don't have to compile, even though we compile, but if you just put the dot, you will see that the partial public field is there. So if I modify the namespace, let's say I make it to change something like this. So if I just change the namespace, and if I came to A, and if I really try to access the partial public field, I can. So let me go over to our slides after excluding those. So you can also have sealed partial. Sealed partial is you cannot inherit it, and it will be merged at compile time if the namespaces are same. So we are very close to ending the class session. It's the conclusion. And whenever you create a class, you create a new type of data. So when you create a string, it's really a string class object, and when you create a list, it's a list type of object, something like that. So another thing about the class, some people I have seen over the years that got afraid that when you see a data structure class or something heard about, this is about data structure. Data structure is just a decent name for class. Don't freak out. It's the simple thing. In data structure, we really talk depth about various kinds of data types, like the list or linked list, something like that. But don't be freaked out. It's just a class which represents a different format. That's it. So now we hit the inheritance topic, our third most important topic in object-oriented programming. So there are many definitions about inheritance, and I really simplified into one sentence and very short, that inheritance is something like getting something from previous generation. That's it. Getting something from previous generation. So let's see a scenario where inheritance is not there. So let's see when we really need the inheritance first. So we have these properties of a person, and a person could walk, talk, and eat. And let's say student also have same type of properties. First name, last name, date of birth, address, gender, something like that. But extra fields, CGPA, completed course, and so on. And he also have behavior like display, something like that. And a teacher also have first name, last name, date of birth, something like that, and method or behavior display. So how we can implement it? We just write the code. So let's see some code. We are in Visual Studio, so let's switch over to our previous project, and here you can see that we really don't have any code. We just cleaned it up, and there is two classes, student and teacher, that I have written earlier. So the data fields that I have copied from the person class, because these are really same, and I put it in data region, and the extended properties like subject proficiency, office hours, department, etc. I put in the extended region, so that I could really differentiate those and really see that which are really extra. And display, in the display method, I'm just saying that his first name, last name, proficiency, and so on, displaying all the fields. That's it. But I'm really copying these fields, and in the students I'm also doing the same thing. I'm copying these all fields from the person class, so that I really don't have to type it, and the extended fields are written here. And in the display property, it's very simple and straightforward. I'm just printing the student details about the class, but we really don't need eat or walking, etc. in our student class, because we really don't want it to be more complicated. So that's it. So let's go to our program and let's really write some code. And let's say I want to make the student class, so student, that's it. So if I really say the first name, or say, let's say last two, last name Romanson, and let's really display our student. And we really didn't initialize the completed course. Let's say 5. Okay, so let's just print it. So you'll see that we have a default date of birth and others are written here. So completed course and so on. So as you can see that it's very simple display class, but what you are seeing that I have copied many properties in both of those student and teacher classes, which is really not good practice. So let me switch over to our slides. The thing that I'm doing, copying and pasting, is really not a good practice. So we have seen the code. So the same things should not be repeated. That's a design principle. So the principle says that do not repeat yourself. Try. And Ruby is really the first programming language that really emphasizes more on this topic. The principle was there, but Ruby really influences or emphasizes it more. And after Ruby, many programming languages really influenced by it. If you really see that what we can do, since we have same properties from person to student, we could make a relationship from the person to student, and this relationship is said to be an easier relationship. So a student is a person, teacher is a person. It seems logical, and let's see that how we're going to do it. So we're grayed out this portion because we have this portion in the person. So what we're going to do is we're going to inherit it from the person, so that we really don't have to write the same properties again and again. For teacher, we're inheriting the person. So since we're getting the properties from the person, so the person is said to be the superclass or parent class or base class. Since the student and teacher are derived from person class, it is known as child class or derived class or subclass. So inheritance, let's say you have a person class ... I'm not putting the all codes here. So let's say you have the student class. So what you want to do is inherit from person. So teacher, you want to do the same, so that when you initialize the student, you could set the first name equals alias. There should not be any problem. So in C# what we do is put the colon in front. That means we are inheriting from the person. That's it. And C# and Java and some other language like PHP only supports inheritance from one class at a time. So you cannot inherit from multiple classes at a time. But C++, programming language like that, supports multiple class inheritance at the same time. So that's really an important point. So if you really say that student is a type of person and is a type of, let's say, X and Y, then it will not compile. It will give you a compilation error. So after that, you just assign the values. Let's see some of the coding in Visual Studio. Previously we have seen our student and teacher class without inheritance. Now we're going to see the inheritance, and we have the inheritance coding in here. So here is my student class, which is inherited from person, and I haven't included the namespace. To include the namespace, I'm just put my mouse cursor and press Ctrl dot to import the namespace, and here I'm saying that op dot polymorphism. That's it. So that's my person, and same thing I have to do for the teacher class. And when I do that, error will be gone, and here I'm achieving the same thing, but I'm not copying the same thing from the person class. In the previous example, as you've seen, that I have copied these properties but the fields, but here I haven't copied those fields. I've just applied the extended field, and it will work just fine as before. So let's see some of those in action. So this time, because it's in the different namespace, as you can see that the namespace is different, so op.inheritance, so I have to initialize, import that namespace, and if I really display it, I'll have the same thing. So this time I really don't have to write the repeated things. So thanks to inheritance. So I hope you understand this concept. Let's move on to our slide. You can create your superclass or parent class or base class from your subclass or child class. If you think about it, the superclass, the person, have some properties. Let's say A for the first name, F, first name, and if you remember from the previous slides, student also have first name, but it also have some extended properties. So the student got more properties than the person. A person requires some of the properties from the student, so the parent class or the superclass can be created from its subclass or from its child class. So you can create person student from a student class or instantiate a person class from a student class. You can do the same for the teacher as well. But if the types are not same, let's say that you want to create a teacher class from a student class, you will fail. And it's also vice versa. If you really try to create a student class from a teacher class, you will also fail. So another thing, that you cannot create your super subclass from your superclass. So that's very interesting. So as I've said earlier, that a student class have all the properties of person, plus it has some extended properties. So it really needs those extended properties to instantiate by a person, but a person has less properties than a student. So a student class cannot be created from a person class. And so if you try to create a student class, student object from a person class, you will fail. And if you try to create the teacher object from the person class, you will also fail. So calling the base class constructor, let's say you inherited a class. Let's say you have a class A, and A is inherited by class B, and you really want to call the constructor of class A from class B. How can you do that? So let's see some example in coding. So we are here in Visual Studio, and we are with our person class, and we have inherited the student from the person class. So let's write a simple constructor in the person class, just like this, that just display that the person is created. Wrong class. So that's it. Now let's go over to any of the inherited class and write your constructor CTOR. So how you can call a base constructor? It's really easy. Write the base, and that's it. A base constructor will be called. So if you really have multiple constructor, it will be very helpful. So if I run my project, you'll see that person is created. So if you remember from the first lesson or first examples of class, that the constructor will always be invoked implicitly or explicitly. So we really don't have to call the constructor these explicitly for the basic, or for only the first constructor. It will be always called implicitly. So if I run, I will get the same result. So it will be helpful when you have multiple constructor. We are going to talk about multiple constructor later in this video. So let's say I have an example, and in example I have class A, class B, and class C, and class B is inherited from class A, and class C is inherited from class B, and I really want to call base methods from these inheritance. So let's see some examples. I have a definition of class A, and I have walk method, base walk. So it will call the walk method. And let's say I have another example of these.walk. So see the difference between these and base. This is all about this lesson. So when I call this, it also calls the walk method, because there is no inheritance there. So when you call base first name, it's just called this, these first name, call this, same. But differs when we call in the inheritance section. So if we call now base.walk, it will mean that point to the function to your base class, or the parent class. That's it. So when we say this, it means a method inside this class, not outside of the class, but this class. So this walk means this method. If we call this from this B class, you have to understand that. So if we say that base.first name, it will represent the first name from the base class or parent class. And if we say these.first name, it will represent these first name. So let's say I have C, class C, which is inherited from class B, of course. So I made a mistake. So let's pretend that it's really inherited from class B. And when we call that base.walk, it will call the base method of its parent class. And these means this method, and base means the parent class's first name, and these means this class's first name. That's it. So this is about the base and these example, that how it differs from one another. We really haven't talked about modifiers, access modifiers in details, and this is the time that we're going to talk about in details of access modifiers. So I really conclude those details from MSDN, and I rewrote those in my words, and some of those are hard to understand from this written description. And as you can see that I have made also a pyramid, so where you can see that the public has no restriction and private has all the restrictions. And in this topic, when you see the assembly, it says the assembly only. The assembly means that it only works for a single project. So in a solution Visual Studio, you could have multiple projects. And if you remember from our project, we have two projects. One is class library and another is console application. So a project means the assembly file. For simplification, we are just understanding that when you compile a project, you will get assembly file. It could be exe or DLL, and whatever it is just an assembly, and we're really interested in that assembly. So let's go to Visual Studio and see some coding about access modifiers. So here I am in Visual Studio in our simple project, and as you can see that we have two projects in our solution. So one is class library and another is the console application. The console application is going to output a exe file. A class library will output a DLL file, and we have referenced the class library file to our project check access modifier. You can add your other projects library reference from this dialog box and go to solutions and add your other projects assembly to your project. So whenever you listen that I'm talking about assembly, you have to understand that it basically means a project. So let's really go over very quick. We have two classes in the check access modifier project. So here I have all the access modifiers written so that you can understand at once. So in a class, when you do not define any access modifier before any member, it could be a method, a property, a field. If you do not declare access modifier, what it's going to be, what the default modifier in the class is private. So a default modifier for a class is internal. A default modifier for a member in a class in C# is private. So a private member cannot be accessed outside of the class. So you have to be very careful about it. So whatever you declare with private or without any modifier cannot be accessed outside of the class. That's it. And if you have an internal, then it can be accessed inside the project or inside the assembly only. That's it. So if you have a protected modifier, a protected can only be accessible if you derived it. It could be derived from other assemblies or other projects, or it could be derived in the same assembly or the same project. So let me give you an example of this protected. So protected and internal, we have already declared the class A like this. So if we really just go dot, you'll see that internal is available inside the assembly, or in this case the whole project, and the protected is not there. Protected is not there. So to access the protected, so if you want to access the protected, let's say you define a class, say just class. It's not a good practice to make class like this. Let's say class D, and class D is really inherited from class A, and the CTOR, if I write these dot, then you can see that I can access the protected member. And this is also true from another assembly or another project as well. We're going to see it. So this is about the protected, and the protected is the most common modifier in PHP, C#, and so on. So what is protected and internal? It means that protected or internal, it will work as protected or internal, both at the same time. So what's going to happen is if you just dot A, you'll get the protected internal, just because it has the attributes or the qualities of internal as well. So internal modifiers are accessible from the current assembly only, or the current project only, so that internals are available from current assembly, as well as it will also be available from other projects. So here I have another class, and let's just quickly so I have already inherited the class from class A. If you see that I have already imported the namespace check class modifiers, and here is the check class modifiers. So what I did is inherited the check access modifier from class A. So if I really write this dot, you can see that I can access the protected internal because I have inherited it, and I can also access the protected Y. But the protected Y, if you remember, protected Y cannot be accessed inside from the project or inside from the assembly without being derived, but the protected internal can be accessed. So that's the difference between protected and protected internal. So then we have public. It has no restriction at all. So far you have seen public, and private we have talked earlier that you cannot access it outside of the class. So we have static as well. Static, to access the static class, static member, you just say the class name and then dot and get the access static member. So if you really want to access the static, you cannot get it by this. After inheriting, you just can only access it by its class name, if you remember from the static modifier lesson. So that's it about access modifiers. If I missed something, mail me, but I think that's it. So let's move on to our slide. Extension methods are released in .NET Framework 2.5. Extension methods are released to solve special kind of problems. Let's say the person class you have seen earlier. Let's say that someone created the person class and give you the assembly file only, and you don't like some of the things that the person class do, and you want to add methods, not modify, but add some methods to the person class. and you can do it by the extension methods. And if you have ever heard of link is based on extension methods. So let's see some of those in coding. Here we are, and let's add our extension method to our project. And you can see that writing an extension method is very easy, but the requirements is to writing the extension method, you have to make the method static. So you have learned the static so far. So you have to make the method static, and then after that, whatever name you choose doesn't matter. You have to put this keyword after the first parameter. That's it. You have to put the this after the first parameter, and then you write the data type that you want to add this method to. So in this case, that I'm just doing it to the person class, and the person class is here. So as you have seen previously, that in the inheritance, if I really add the inheritance to my project again, so what happens in the inheritance is that we have methods that already exist in the person class. But let's say that we really want to add something to the person class, and so that that extension would be populated to the student as well. And by this example, you can also modify the string class. Let me give you another example. So in previous days, if you really want to convert a string to double, what you do is double dot try parse, something like that, or parse, and then pass the string. That's it. So we have to do like this. So if we really want, let's say I have a number and I want to convert it to double, there is no method. So I have to call the double class and then call the parse method to do it. So let's say that I want to add a method to this string class so that I have the two double methods, so that I could use it and get the double from the number. Let's do it pretty quick. So public static void, and then whatever name that you choose, to double. In this case, I'm choosing, and then this, and then I'm saying string. Then I'm saying that str, and we really don't want to pass anything to our function. We just want to invoke it. So in the return, rather than void, we're going to return something. In this case, we're returning double, and return double dot first dot str. That's it. So if we just go to any class, let's say any portion of the app, let's say in the program, and we have to include the namespace or namespace of the extension class extension. So let's just delete those or exclude those files so that I don't end up having an error, and import this person so that I don't have any compilation error. Let's see, do I have any compilation error? So I have. So let's access modifier. Okay. Student, you're not really interested in this right now. So let's just compile, and we're successful. So let's really import our extension namespace extension method. That's it. Let's say we have a number, var number, and it is coming from a string. That's it, string, and we want to double. That's it. Now if you hover over, you can see that it's a type of double that we just added via extension methods. So it's that simple. And another thing I really want to show as an extension method, so that you can understand that you could add more things to any fixed class. So if you see the person class, it's really fixed. We are not adding anything here, but we really want to add something so that it will eventually come up in the student class and in the teacher class. So that's the extensibility that we want to have. So by this extension method, we're going to have this functionality. So let's create the person class again. For student class again. So we haven't included the namespace. See, you have the extension method from the person by using the extension method example. So it may require some properties. That's the first name, alias. Just give the alias and run it. You can see that alias is eating because the method calls the eating method. So that's it about extension methods. If you have any more questions, you can shoot. But here I'm just showing the basic things. There are really very broad topics about extension methods. So and system.link is really the best example for extension methods. Now we're at the fourth topic at our object-oriented programming, and this is called the encapsulation, and most people really forgets it. And I'm going to give you an example, real life example, so that you could remember it for the rest of your life. So let's say we're selling something. In this case, we're selling burgers. So one burger is $5, 2 burgers are $8, and 3 burgers are $11. That's it. We put the price tag, and let's say we put a money bowl so that guys could take the burgers and put the money in the bowl. So what do you think that happened in real life? So the thing is going to happen is most people are not going to pay the exact money. Some may pay, but this is not really a good practice. So you cannot run your business like that. You really don't have a guarantee that you are getting the exact money that you really ask for. So that's really a problem. So what you can do to solve this problem? So you can do is box those or encapsulate those in terms of programming so that no one can get the burgers easily. So what does that mean by easily? So that if anyone wants to have a burger, they really have to go through the layer of protection. And by this protection, I mean that if they pass the exact money, $5, and they will get the 1 burger. They will not get 2 burgers. So if they pass at least $8, they will get 2 burgers. That's the concept. So from this concept, encapsulations came in. Encapsulation, also known as data hiding or data protection. So let's see some code on encapsulation. So far you have seen the fields in my examples. I haven't introduced the properties, and this is the time that I'm going to introduce the properties. But let's really see that how other programming language encapsulate, and then we'll go to the C# way. And these ways still works on C#, but C# has better way to deal with it. So let's see that how other languages do the encapsulation. So let's say you have a first name field in your class, and to hide this field, you really don't want to express it as a public. So far you have known the access modifiers because I talked about it. So if you don't know access modifiers, go back and watch the video again. So it's private, so no one outside the class can access this field. So to access this field, what we can do is write a method named getFirstName and then return the first name field from the class. Since it's a public method, anyone can access it, and the data inside the class will be passed through. And to change the field, we have let's say we have a protection like that. If name is null, we are not setting the name. The name has to be something string concrete. We're not checking the empty here, but let's just assume that null is doing the same thing, checking empty and null. But it's not the real world thing. Just assume that it does. So we're checking it and then putting the name so that it's really appropriate. So think about that. If you have more validation, like you want to check some format or check some pattern and then keep the data, it's the best practice. So that when people change the data, you can check that is it in right format or right pattern, and then you save it to the database or save it to your field, something like that. So this is how the encapsulation is done. So these are known as getter, and the set properties are known, set methods are known as setter. So in C#, what we do is just write the public string first name and then use the curly braces and say get and set. The get and set implicitly means that we have a method named getFirstName, which is really returning, which is the get here, which is really returning the first name, and the set here is really going to set the first name from the name string that passed in the parameter. So simple getter setters are implemented just like one line in C#. That's really very elegant, I think. So what you do when you have conditions like this, what you do. So if you really want to explicitly define the getter and setter, what you can do is after the get, you can use the curly brace and let's say you do some stuff up there and then return the first name. But the recommendation is do not do any heavyweight calculation in the getter method, because we really want our code to be efficient. To do many of the things in the get method will make your program slow. So the best way to change your first name or the field is in the set method. So if you have any validation kind of thing, do it in the setter method, not in the getter, so that it reduces the time. So this is exactly the code that you have seen in the set earlier. So instead of name, that in the set method, if you write a method, we could name the parameter as anything we like. But when we use C# and use the properties like this, the default parameter is always the value. So when you say value, it means the parameter that passed in. So we're checking the value. If it is not null, then we are putting it to the field. So you really have to have a field when you are explicitly defining it. Other than that, you really don't need another private field. Now let's see some coding. We're in Visual Studio and I have codes for encapsulation. Let me include those. So far you have seen the public fields. So here we have private fields. These are fields, and we're doing this by the old programming way, the getter and setters, as you can see that I have made those getter and setter. We really have only 2 fields, so that you could understand. If you have more, so you have to write more methods like this. So to make it better, we're going to move on to the C# way. This is the C# way. You can write it, the get and set. So if it is just get and set, what you can do just write like this. That's it. So as you can see that we step by step upgraded our code. So first we are doing it the regular programming style. Second, we're doing it in C# style, and then we're moving on to the only implicit style that we're not defining the code. And in the for, what you can do, let's say you have a public field. Let's say you have a public field, public get, but you really want the set to be private. You can do that. To make the set to private, just write the private in front of set. That's it. We compile just fine. If you really want the get to be private, don't want it to be go outside, just write the private in front of it. That's it. Build works just fine. That's it. So if you have any more questions about encapsulation, let me know, email me, I will reply. So let me go over very quick to the slides. Nowadays, modular approach is very common, and so far we have seen is a relationship, what we have seen in the person and student relationship. That was the is a relationship, and has a relationship is really said to be the modular approach. So when first NASA was making the space satellite, it was really very hard to put up that huge thing up in the space. So what they did is they break this satellite into smaller modular pieces so that it could be go up in the sky very easily, and then combine those and work with it. And each of the modules will be designed such a way so that if any of those are broken or chopped off, the rest of the modules will work just fine. So that's the modular concept. So if smaller things breaks in the system or changes in the system, it doesn't affect the whole system. The system remains the same. So let me give you another example that you see in the market. That's your motherboard. So your motherboard is really designed in such a way so that it works if some of the things are not there. So your motherboard is also required a processor, a RAM. That's it, and power supply, of course. But other than that, if you don't have a GPU, it will work just fine. But some of the motherboards really require a GPU, but in most cases, a motherboard doesn't require a GPU or additional RAMs. If you have one RAM, it just works fine. If you want to add many RAMs, you can add it as much as you like. So that's the modular approach. And you can also add your TV card to your motherboard so that you can watch TV and so on. So if you see the bike, we really want to make this bike based on modular approach. So what we really want to do is, as you have seen, that we have made these into pieces so that we could have the modular approach. So we want a part that's really contained with the tires so that we could add one or more than 2 tires. As you've seen in movies that they have cycles which has more than 2 tires and more than 2 seats, so that there could be 2 people could sit on the bike or cycle. So something like that we could design based on the modular approach. So you may have the idea that what we want, so we just break this into smaller pieces. You can see the images. So that's for the theory. So what we want to inherit the bike this case the bike, inherited from seat, handle, body, tire, pedal, chain, etc. But the problem is C# supports one class at a time inheritance. So you cannot inherit from multiple classes at once. Some language does support that, like C++, but Java and PHP and C# doesn't support that, or VB doesn't support that. So what can you do about it? The way that you can follow, if you really want to go with the class approach, that you make a class of chain, and then what you can do, you make a class of pedal which inherits from the chain, which is not very logical. If you really think that this should be separated, this shouldn't be, but for the sake of work, we're just assuming that that's how it's done. And then we have tire class, which inherits the pedal class. So inherits the pedal class, and then we have handle class, which inherits the tire class, and seat class inherits the handle class, and the body inherits the seat, and the bike inherits the body, and so on. So that's how we get the cycle. It seems like a modular approach because we break it into smaller pieces, but in the terms of modular approach, what we have talked earlier, that if the smaller piece is broken, the other things should work. But in this chain of command, if any of those are broken, the others will not work. So it's not really a modular approach. So what you can do is look for interfaces. So interfaces are the way to do the modular approach. So what is an interface? An interface is like contracts that you must implement in your code. So an interface is like, as we've said, that contract says something, 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 and you refer that, if you refer that interface in your code, let's say in class, and if you do that, then you have to implement these conditions in your class. That's it. That's the interface. So let's see some of the examples in coding. We're in Visual Studio, and here we have our interface examples. And for this interface examples, I have used the Visual Studio diagram tooling system, the class diagram tooling system. Many developers don't use it because, but I really like to use it when I have many classes and diagrams. It's really easier to work with it. So let's really go to the diagram to see that what I did. So what I have is a savable interface. An interface is just a contract, nothing else, and it's really easy to write. Let's just go to that interface. So that's the interface. I have a property and I have a method. By default, all the properties or method you make in the interface or write in the interface are public. That's it. And whenever you say that your class is dependent on an interface, and you can do like the class as you have did in the earlier class, just go to the modular example 1. So in the class, what you did is put the colon and write the class name to inherit from that class. So if you really want to implement the contracts of an interface, you just have to write the interfaces by comma. That's it. So you can write multiple interfaces, but you cannot write multiple classes to inherit from. So that's the thing. So after I did implement the iSaveable, because I have iSaveable here, which has changes and save methods. So when I did implement this, what happens is, let's say I don't have any code, just put this code away, clean up, and let's say I write manually that iSaveable. So when I write iSaveable, if I try to compile my code right now, I will get the errors that says that I didn't implement the changes property and save method. So I must have to implement this. So if you really want to implement, you could manually write the methods or go to the interface and then press Control and then dot. You will see that option comes up and says that implement interface isavable. Just put enter and you will see the methods that you have declared in the contracts will be written in your class. That's it. Now it's your job to implement those methods properly to work with your application. So that's how you can work with interface. So let's really copy paste our code. So I haven't done anything. I just made those regions. I just implemented those so that you understand that whenever I make a class dependable of an interface, it should be implemented. That's it. I really like to have regions in my code. So the easiest way to have to make more interfaces by the diagram tool. Let's help you make another one by diagram. Let's say I have modular example 4 class, and I really want to have an interface name I test, and I want the properties or methods. So if you don't see this option here, the details, you can go to view and then others, then class details. You'll see this doc toolbox, and you can write the methods that you want to implement. Let's say test and example, 2 methods, and you can change the types from here. Let's say you want an int, an example, and if you really want to have parameters, let's say x is a decimal, something like that. If you want to add another parameter, so it's a double, so on. So to make it dependable, what you can do is you can click on it, toolbox, and just call it like this. Then the methods will already be implemented in your code. Just double click it, you'll see it. It's that easy if you just use the diagram. So how to get the diagram? It's really easy. Go to add, new item, and go to class diagram. We have to find the class diagram, and add it to your project and design your classes with it. Let's really go over our modular example 2 to see that how I implemented or what I did different in it. So let's say you have a save method already exists in your class, and you want or you implemented a interface that also want to implement a save method. So how you're going to distinguish those two? The easy way to distinguish or do the right thing is explicitly write your interface, then the method name. That's it. And it's just a returning function. It's not a public function, but you could write a public function if you want. Oh, sorry. So if you make it public, you'll get a compilation error, because compiler will be confused that which function it will call. But inside the class, you can have 2 same name function. One is private, one is public, by using interfaces only. That's it. And you don't have to make the parameters different. You can have it. It will compile just fine. That's it. And another thing about the interfaces, even though that the interface was designed to make sure that you implemented the contracts, So sometimes you will change the previous contracts, but the best way to do, let's say that I really want to add a new method to this iSaveable. Let's say that I want to add, let's say that void new method. So what will happen that it will break all the codes around the whole application. So that's we don't want. So if you now build it, so it will complain that most of the classes doesn't implement this new method. So that's a problem. That's really opposite of what we are trying to do. We're trying to make that if smaller thing breaks, the system will work just fine. To solve this problem, what you can do is write a new interface and then implement or inherit your class from that interface again. So what I really meant to say is, let's say that you want to make that new method to append in your modular example 2. So rather than writing it into iSaveable, you write a new method and interface, and interfaces starts with I, capital I. That's the C# convention. Let's say a new interface. That's it. And write our method, the new method. New method, and we want to implement this new method to our modular example 3. So get the inheritance and just drag it. That's it. You get the inheritance list over here. So if I just go to the code details, I'll see that new method is implemented, but my other code didn't break. So that's really important. So let's go to our slides and go over very quickly. So far we have seen destructors. So iDisposable is another example of interface and destructor that really works better than the class destructor. What is this? Let's really go to the coding and let's see that we are in Visual Studio. So let's see some coding. I am assuming that you have seen in many places that using keyword, or if you haven't seen it, you're going to learn it. So what the using keyword does is you create an object, like say that person, new person, and you want that person to be destroyed after this execution. So using means destroy the person object or keep the person object inside this block of code. Keep the person object lifecycle inside this block of code. This is the using means. So you can use this keyword if you have an implementation of iDisposable in your class. That's it. That's when the iDisposable is needed, really. So if you really go to this interfaces, you will see that there is a class, destructor class with iDisposable. So when you really implement the iDisposable method, iDisposable interface, you really have to implement a method called dispose. So a dispose method does is it calls as soon as the using block is done. So let's see some example. Let's certainly do something here. Right line lower. That's it. So let's run our project. You'll see that class is created. It's from that destructor. We have class is created console write line, and then we are printing the capacity like the previous, and then the dispose method is called, and then the hello world is called. So if you really go to the method, class is created, capacity is printed, and then as you can see that the destructor was never called. The destructor will call if we set this to null and if we call the garbage collector in. So as you can see that it's a very advanced and very quick way to dispose your classes. So let's go to the slides again. So far we have seen adding a new method to break our existing code, so we have to make another interface to make it more modular. So that's really very important point. Now we're at the fifth step of object-oriented programming, which is polymorphism. And there are really various definitions of polymorphism, and many websites defines it differently. I simplified it this way. Polymorphism means same thing in different kinds. So to simplify that, let's say you have a toy. Let's say you have a toy and it's just a toy. And it's the same toy you can buy in red, green, and blue color. That's it, the three different flavors. That's polymorphism. That's the real life example. So let's see how to implement polymorphism in your code. So when people ask in interview question that what is polymorphism, you can say that same thing in different kind, and then say the programmatic way or the programmatic definition that how you can implement the polymorphism in your code. The way is inherit your class from a base class. That's the first step. The second step is override a method from a base class. So you have to override. We haven't seen override yet, but we're going to see it right now. So override a method from your base class. In C++ or C#, you have to mark the method as virtual. But in Java, you don't have to do this. So keep in mind access modifiers, because these are going to be problematic if you don't remember. And this is how you implement the polymorphism. So keep in mind the access modifiers. We're not going to go over those again. Keep you in mind that access modifier is a big factor in this polymorphism. Let's see an example. Let's say you have an animal class, and animal have some properties that we don't want to see. Let's say they have some common properties, and they have a method called talk. So when we call the method, let's assume that the print method actually console.writeLine, and it's actually printing that generic animal talking. That's it. So as you have seen in the earlier examples, inheritance, that you can inherit from person to student and person to teacher, and we're going to do the same thing here. So what we're going to do is we are going to inherit the animal class, we're going to inherit the dog class from animal. But we really want to change the talk behavior, because dog really talks differently. They bark, and it will be really illogical to have the generic animal talking. We can have that, but let's really assume that we have a different class, the different class which really represents the different object. So from the animal, we are defining the dog. So to implement the dog, we really need something different in the talk method. To make that talk method different, we really need to override that talk method. So we're really saying inherits, but here you really have to put the colon in the C# and override, and dog just say oof. That's it, returns oof. So how we're going to print it? Print dog.talk, and we will see in the console that it says that oof. That's it. So let's say we have another class called cat, and we really want its behavior to say meow. So we're really overriding the talk method in the cat class, and it's very simple and straightforward. I don't think it would be a problem to understand. And when you call the cat.talk, it will say meow. So let's say you have human, So human says hello. When they talk, they say hello. That's it. So it's pretty straightforward. Let's say I want to implement, I really didn't implement the get method. I really didn't override the get talk method. So what will going to happen is it's a void method, so and already have a print, so we don't have to put it in the print. We just say cat.talk. So when we call that method, it will print out the generic animal talking. That's it. So let's see some of those in coding. I'm in Visual Studio and I have examples for polymorphism. Let's include this. So for this polymorphism, I have introduced the new person class with person poly. It's not really different, but it has virtual keyword in front of the walk method. So if you see the regular person class, it doesn't have any virtual keyword in front of it, but here you have a virtual keyword before the walk method. So in C#, if you want to override a method, you really need the virtual keyword in front of it. So if the developer doesn't put a virtual keyword in it, so if they don't, you cannot override it. So if they do, that means they're allowing you to override their method. So if they don't have that override, you could still modify it by the extension method. Remember the extension method I showed you? It was specially designed to solve this kind of problem. So now if I really want to implement this walk method, if I go to my polymorphism 1 example, you can see that polymorphism 1 inherits from person poly, and it's just a simple constructor, and here I'm overriding the method walk. And in the walk, it will say that the first name, the base.firstname, as we've seen that base and these means. So base.firstname is walking from polymorphism 1 class. So I think I have an example of it. Let's see. Okay, here is an example of polymorphism. I just created the first polymorphism 1 class, poly, and then ask it to walk. And if you really go to the default walk method, it said that the first name is walking. That's it. But if it's really overridden, then the method should look like this, that the first name is walking from polymorphism 1 class. So if you're really successful with overriding the method, the walk method will display that it is from polymorphism 1 class. And then we're changing it, and then again say poly.walk, and then we are having the polymorphism 3 class. Let's go to that 2. Let's see that what we did in 2. So in 2, what we're doing is calling the base method. So the base method is actually the method here is walking. So if you call this walk, it will print, it will first print this, that the Alice, if the first name is Alice is walking. And second, it will print that Alice is walking from polymorphism 2 class. That's it. And if you go to the polymorphism 3 example, you'll see that it only says that print from polymorphism 3 class, but different thing about this class is overriding. So overriding is a type of polymorphism. It's really called static polymorphism, or sometimes called ad hoc polymorphism. But if you're asked in the interview question that what is polymorphism, and if you really say that override, they will judge you that you are wrong. But in spite of that fact, Wikipedia really defines it as a polymorphism, so you can reference it if they don't know it, because I have seen many people don't know it. So you can say that overloading, sorry if I misspelled, that overloading is a type of polymorphism said to be static or ad hoc polymorphism. So what is really overloading? Overloading can be achieved by same type of name in the method but with different parameters. And parameters different means the parameters could be the type different or the number of parameters are different based on two concepts. So if you have a return type different, it doesn't matter. The compiler will give you an error. So if you have two methods like same, and if I really try to compile it, I will have an error. But if I have a different parameter or additional, so it is complaining that we have same number of parameters. It was just fine, sorry, the mistake. So let's say we have another thing and let's just compile it and it's just fine. So this is how you can overload a method. And another thing that you can do is just change the data type. It will give you an error, so just comment out and then build and it's just fine. This is called overloading. These two ways you can overload a method, and overload is said to be static polymorphism or ad hoc polymorphism. It doesn't have to be implemented after overriding, after inheritance. It can be done anywhere in the class. If you have same name method, you could you're mostly overloading those. And the great example of overloading is in the console.writeLine method. So if you just go to console.writeLine, you will see that there are 19 overloads. The overloads are shown like this. So if you go that it takes a parameter with boolean, it takes a parameter with character, something like that. So these type of functionality are given to make the programming much more flexible. So as you can see that in the tree I have lots of those parameters, lots of those overloading methods based on walk, first name, last name, so that I could change the first name, and I could also, let's just delete this, we change the first name. I could at the same time change the first and last name and change these properties, change base properties. Base property is going to change the parent class properties, something like that. So let's really print out our console program. See that Alice is walking from polymorphism 1 class by this method, and we change the Alice name to hello, and then hello is walking, and then walking from polymorphism 1 class. Yeah, hello is walking from polymorphism 1 class. So far that's correct. So after that we are creating the polymorphism 3 class, where we are calling the base class of we are just calling the, let's just go over quick. Just go to this. If you can go to any method by stepping into the method and press F12. That's it. You will go to the definition of the method. So here you can see that I have comment out the base.walk. So if we have base.walk, what will happen is we will have Alice is walking again, and then Alice is walking from polymorphism 3 class, and then we have also changed it to hello, and then call the walk. It will do the same thing, and then we change the properties, these first, these last, base first, base last, and then console print out the first name. The first name will be this name that we have changed, if you see that this first, so poly first name would be this first. As you can see, that this means the upper class that you are seeing, and rest of are very easy. If you have any question, because it's very complicated if you don't spend some time, so I suggest you to download the code and spend some time in it and try to understand. It's very simple, but if you really watch the video, it will be complicated, because some of the things I feel complicated right now, because I have to go through the code and really understand that what it's doing. So really download the code and go through the code. It's really easy, but you have to spend some little more time in it. That's it. Let's go to our slides. So we haven't done the toString method, overloading toString method. So with every object you will get the few methods that are tied with the object class. In C#, everything is derived from the object class. So object class has few methods, toString, equals, something like that, a few methods. So these methods are common to every primitive type and every object in C#. Whatever you make, whatever class you make, that will be there. So the toString method is very common. Let's say you have a number and you want to make it toString, and you just use the toString method. That's it. So let's say you have defined a new class and you use the toString method, and then you will see the name of the class and with the namespace. So if you really want to change that toString method to behave differently, you can just override it, and that could be your assignment to try it out. It's very simple. So method overloading, we have talked in the coding that it's ad hoc polymorphism, or said to be static polymorphism. It's very simple to do. Calling by base class, we have seen it, and static modifiers, you can check out the links. Generics were released with .NET Framework 2.0 around 2005. Generics is released to solve special kind of problem. And if you know C++, templating, it is similar but not the same thing. And in this session we're going to talk about very basics of generics. We're not going to go very deep into it, and the reason behind I'm talking about generics is because it is a type of polymorphism. It's known as parametric polymorphism. So let's see some of those in coding. I'm in Visual Studio and I have an example called vector. If you have ever done any C++ programming, you'll know that there is a data type called vector, which implements the array and abstracts the way that abstracts the limitations of array and give better functionalities. So we have the same thing in C#. It's called the list. So I made a new data type called vector, and I really didn't go through the underlying coding, the complexity. I just make the list to work behind the scene. That's it. I just use it to prove or show you the generics. That's it, nothing else. So that's why I make the simple code. So whenever in C# you'll see these angle brackets, you have to understand that this is the generics. That's it. And the thing that put into the angle brackets are the data type. The data type that you put, the system will be look like that. The object or class will be look like that. So here I have the list or the vector only for integers. So whenever I create this vector, I will have only the integer numbers to add in the list. That's it. I have the add capabilities. I just call the add function, and in the constructors I really make the capacity to 100, and you can change it by explicitly saying the capacity in the constructor. And it's really very straightforward code. I also have a new additional method called print all. It will print all the list items in the console, and you can get any positioned item. and you see that it works like an array. To have this third bracket working in my class, I have to overload the operators, but I was really very lazy at this point, and just go over very quick. I'm in my main program and I may have an example. Okay, this is my vector class that I have created with 200 capacity, means 200 items are already created in the array as now, and then I'm adding the items to the array and printing off. That's simple, that's it. So let's really print it. 23, 123, and hello world is the print statement. So let's really minimize that. Print off. So the problem is you cannot add a string to this class. If you do this, you will have an error. To solve this problem, the generics are introduced. So we have also a generic class for this vector type, and as you can see that in the previous example I have used the int, and here I'm saying t, and the t came from the template name that I have defined after the class name. So to make a class generic, what you can do that put your cursor after the class name and use the angle bracket and then name of the template that you want to use as generic. And if you have more than one template, write it with comma more. That's it. So if we really want to replace that t, just put this name template and it will work just fine. So and in most example you are going to see the t because that's really very common, and try to use the common names because it will be helpful, and that's it. It's not very a rocket science. So whenever someone creates your class, they're going to put the data type in between those angle brackets, and you're going to have the benefit, or they're going to have the benefit of generics. So let's really compile this and put this to t, and let's, for the simplicity example purpose, let's keep another template parameter name more. So what's the problem there? And okay, so let's remove this. Well, and successful. So let's really see this in action. Our program. Here is my generic class. Previously it has only one generic parameter, but now I have used another generic parameter which is more, which is no use in the class. As you can see, when I comma, I will see the parameter name and I will see that int. It's actually nothing, but let's say it's in. It is not going to use in the application, but to make you understand, I just gave two names in the templates. So if you have two names or more than one names, you could use it. So here I'm adding the string because I'm taking the string template. If I take the floating template, then I could do it with floating numbers as well. So if I print it, run it, it just prints the things that I put in the list. That's it. That's simple. So let's go get over to the code slides, and so I'm in the slides. So let's get over this very quick. So why generics? If you are a C# programmer, and I have talked very recently that every type in C# is implemented or inherited from the object class, even the primitive types. So why need generics? We could just write the object. That's it. And the generics comes for the performance impacts. It really makes a huge difference on performance when it comes to work with maybe 2000 or 10,000 data. So try this example. If it compiles, I haven't compiled, but I really assume that it should compile, and try it with 10,000 data, and try it with integer, string, floating points, 10,000, and compare the times with this class, this T class, if it works. And if it doesn't work, then find the code or debug the code or Google for it, find a solution, and then compare the performance. You'll see the better performance will be gained by generics. That's why generics are there. And when you do something like these boxes, the C# under the hood does some boxing and unboxing. So boxing and unboxing is good for some time, and for these type of scenarios, boxing and unboxing really make a huge impact on performance, in a negative side, of course. To enforce the polymorphism, what you can do is use interface, either interface or abstract class. We haven't talked about abstract class, but it's really same as interfaces, but an abstract class could have definitions with other methods, but an interface will never have any definition of any method. That's the difference. And nothing is different than the contracts. The contracts implementation are really same. If you don't implement the abstract class contracts, you will get an error in the compile time. So let's say you have a class and you really want to enforce the polymorphism of this talk method. So how you can do it? You can do it by abstract class. Just put the abstract keyword in front of your class and make a method public abstract, so that it must be implemented by the developer who implements the class or inherits from this class. That's how you're going to enforce the polymorphism. And good thing about abstract class is it could have definitions and interface couldn't have, and we're going to see some real-world examples how you could use interface and abstract class in the strategy pattern. But for that time being, just keep it simple. Let's see some coding. Previously you have seen that to do the polymorphism, what we did is put the method as virtual keyword in the base class. So to work with abstract class, we just put the abstract keyword and put the method as abstract. Must put the public. If you don't put public, it will not work. So if now that this class is not implementing this method, see the error that it's not implemented. Oh, so you have to remove the definitions as well. So remove the definitions. So if you just go and build it, you'll see the error that it doesn't implement the walk method. So this is how you are going to enforce the polymorphism in your code. So we just keep it as it was. That's it. So abstract class versus interface, it's a very interesting thing, and you should know those. These are very important. So abstract class can implement or share common implementation, but on the other hand, interface couldn't have any implementation. It will only keep properties and the method names. That's it. And single inheritance supported only. That's really downside. downside of abstract method, and a class can inherit multiple classes. It's really upside for the interfaces, and members can have different access modifiers, and this is also an upside that all the members could be different. All the members shouldn't have to have the same modifier as public. You could have some hidden layers, and you in the interface you really have to have all the members as public. It's really a downside. So may contain constructor, destructor, public properties, functions, and so on. Contracts will be the abstract methods, and for VB it is must inherit, if I'm not wrong, because I have done VB very long time ago. So the abstract, instead of the abstract, if you're doing VB coding, put the must inherit keyword. That's it. And may only contain properties and functions, contracts. That's it, nothing more. But it can also hold implementation of functions rather than just the contracts. So these are the upsides and downsides. Now we're going to talk about the strategy pattern, and it is going to be a very good example for what you have learned throughout this session. And why we need this: over the years I have seen a lot of hardcore developers overuse or overdo inheritance. So what happens is eventually they will end up with a very inflexible system which is very hard to modify, even though they implemented all the OOP concept, but they design the system in such a way, or easier relationship, they follow easier relationship that much hard way, so that the system becomes so inflexible that it becomes very hard to modify. Or if you change in one place, the system breaks, the whole system breaks. That's a really problem. That's really against our modular approach. So let's see an example of bird simulator to address some problems. So let's say we have a bird simulator abstract class. The abstract class is named as abstract bird. That's it. So the class have some properties like the color of the bird or how it speaks, something like that, and have some properties like display method. The display method should be unique for every bird, that how they display, and the fly method should be void, and it will print that they're flying or not flying, and speak method should be how they're speaking. That's it. So we're really interested in the display method, but let's see that how it goes, how the design goes. So let's say that I want to implement a parrot class from the bird abstract class. So what I did is made a concrete parrot class from the abstract class, and then write the display method, and when I print the display method I see the parrot object. So let's say I have another bird which is penguin, and I inherit from bird, and when I display it I see the penguin. But penguins have a special ability that they cannot fly, but they can swim. So they have special ability they can swim, but they cannot fly. So I'm really making the fly method to private, and we really have to write these speak methods differently because all of the birds speak differently. Let's say we have ostrich, and same thing, display method we have to write ostrich do not fly, so we are changing the fly method somehow, and changing the speak method as well. So let's say we have a rubber bird, and rubber bird don't fly, don't speak, display as a rubber bird. That's it. So what you have seen in this example, you have seen that many places I have to private fly. So instead of private fly, if there is a complexity in the method, I really have to overdo all of these methods in every places. As you can see that in most places I have to rewrite the 3 methods at all, because we have the 2 different kinds of bird. So assume that here we're talking about bird, but in a business application you are going to have different kinds of object. Bird have some similarities, but in a business application you have very less similarities. So what is going to happen is you end up writing the every code or every function again and again. So it's a really bad solution. So let's see our observation. In a simple perspective view, it's a good design, but there are a lot of code duplication in speak fly behaviors, as you've seen, and we don't want our code our code to be wet. We want our code to be dry as much as possible. And think, if you have 100 methods in a class, it could possible. Some business apps really have 100 methods in a class. So if you're really doing such things, so what will happen is you will end up writing these 100 methods in 100 different places. So that would be really tedious and a very bad solution for your problem. So if you remember from the previous slide, we could use the interfaces, or could use the hazard relationship, so that we could achieve the modular approach. So let's do it then. So in this case we have abstract bird, parrot, penguin, something, so on. So let's say that we have iFly interface, and which have only method fly, and we have another interface called iSwim and iSpeak, and so on. So parrot only implements iFly and iSpeak because they speak and they fly, but they do not swim. So penguins, there are swimmers and they also speak, so but they do not fly, so they're not going to implement the fly interface. And ostrich only speak, they don't swim, don't fly. And if we really observe the design, it's really a good design. There is no confusion with it. The problem with this design is that if you have 100 or 20 classes, then you have to write the same methods every time, which is also a very wet solution. You're writing the same type of code again and again, which is very, very tedious, which may seem very good, but very tedious. So again, we're stuck with the problem 100 methods. We have to write the 100 methods again. So we really want to reuse our code, and we can't do it here, so it's a big problem. So let's really do something about it. And if you remember from the abstract class versus interface, there is the solution exists. So the solution can be done by analyzing the problem or doing the problem something differently. So here what we are doing is, in the properties we are saying that abstract class should also have iFly behavior, iSwim behavior, or speak behavior as well. And we have these 3 methods. So if you have a real-world application, you would have the relative methods for that application, and we have an abstract method called display. So what we're going to do is we're going to make the interfaces again, but this time, rather than just to have the interfaces, we are going to implement classes from this interface. So we have a fly behavior, so which implements this interface iFly and implements the fly method, and we also have no fly behavior, which will say that the bird cannot fly. So it's implemented. So if you have 10 different type of fly behaviors, just write the 10 different type of fly behavior. It's really will be odd if you have 100 types of fly behavior. So that will be a good solution. So if you have 2 types of fly solution or 10 types, just write it down or write the class for that type. So swim, we have swimming behavior, no swimming behavior, and so on. Speak, no speak, or silent behavior, or something like that. So what we're going to do is we're going to initialize these behaviors based on our object or based on our requirements. So let's see some of those in coding. I'm here in Visual Studio with my strategy pattern solution. So I really designed the solution by the class diagram. As you have seen in the slides, I have done nothing differently than the things are in the slide. So I have iSwim interface, iFly interface, which has a fly method and fly behavior, a class which implements the iFly. So it has a fly method, and if you just go to the code, you'll see that I'm flying. That's it. That's how simple it is. So that's our bird class, abstract class, which has 3 behavior properties, which is based on iFly, iSpeak, and iSwim. And if you just go to the code, here in the abstract class, I just implemented these 3 interfaces, and I really have 3 properties, public properties, with iSpeak, iFly, and iSwim, and I really have a constructor, an explicit constructor, which really required to specify those 3 things. So in those methods, so I have fly, speak, and swim method. So what this does, it really just call the swim behavior.swim. So whatever behavior we pick in the creation time will be just called by the method. That's it. So it's doing nothing interesting but just calling the behaviors. So if we have an error, we are just printing it to the console. That simple it is. So let's go to a class called parrot, that how we implemented it. A parrot implements from bird, and in the base constructor, in the constructor, I'm calling the base constructor with new fly behavior, parrot speak behavior. I have a parrot speak behavior. Yeah, this time I really use the class diagram and copy paste some of this, and so some of the speak behaviors are in the speak behavior.cs file. So as you can see that I haven't put those into the separate files, so I got confused that where it is. So the best way to do this stuff is to put those into separate files. So I have the parrot speak behavior class, which implements the iSpeak, and in the iSpeak, in the speak method, I'm just saying that parrot noise. That's it. So every bird has different noise, so that's why I just write the different noises, and for generally I just put the bird noise speak behavior, and in parrot I just implemented the parrot speak behavior. And parrot doesn't swim, so I just introduced the no swim behavior, and if you just go to the no swim behavior, can find might be in swim behavior. So no swim behavior, I can swim, and swim behavior says I'm swimming. That's it. Everything is very simple. Nothing is complicated here, but you really have to go through the codes and really have to take some time if you're new to the coding, because if you don't do that, it will be really hard for you to understand. And that's it. And in the display it just says that I'm paired, and this is how all the others are implemented. So if you just go to the program, it's a console app, and I'm creating all the birds and displaying, flying, and calling every method. And let's say that what's happened, ostrich cannot fly, so in the fly method it will say that I can fly, but after that I'm modifying the flying behavior with the new fly behavior. So if I call the fly method, then it can fly. So it's pretty simple. Let's just print it out and describe every line. So this is an ostrich from this display line, and it cannot fly because in the flying behavior we have no fly behavior. And after modifying the fly behavior, it's just a printing statement, and then I'm changing the flying behavior by new flying behavior, and then it can fly. So in the noise speak, it says ostrich noise, and swim, it cannot swim. The parrot displays that it's a parrot, I'm flying, parrot noise, I cannot swim. So this is how all the others are implemented, and rubber bird is in silence. That's it. So go through the codes, dig into it. If you have any problem, mail me, I will get right back to you. So it's very simple, and try to dig into the code, otherwise you can't get it. Let's go over to the slides and let's see our observation. So this is the much better solution than all the others, and at this point we could design or extend our design to any level, and we will have really less problem, and it will be highly configurable. However, it solves many of the problems, but there is no silver bullet for every problem scenario. So use this pattern when you think that it will work. Don't make it a silver bullet and try to solve every problem with this solution pattern. That's it. Finally, happy coding. Try to make your coding more modular and readable. And to make your code readable, don't forget to use the naming conventions. In the demo coding, I really haven't shown you the naming conventions, but it's really a good practice when you write real-life code or enterprise code. You should follow the naming conventions. It's really very helpful and make your code much more readable. Another thing I really like to show, and that I do in my coding in personal life, that you can make your code more readable by Visual Studio documentation system. So let me switch over to Visual Studio for now. So I'm in Visual Studio. So what you can do, let's say you write a method and you want to give some hint to the developer who will use your method. To do that, you could use a 3x/ and you will get a summary. So let's say you have a method, let's say it has a string param, let's say a string param, and if you do the third / you'll get a summary session. So let's say it's a method, just for simple, and it's a param. So when a developer accesses your method, let's say that I'm accessing from here. So when I say, what is it? It was eat. So when I say eat, see that you will get the description of the method. It is a method. So whatever you write, you will see the description. So it is really helpful for other developers who will use your framework or assembly in their development life. So make your code much more readable by these documentations. And you can also manage your documentations by the class diagram that I have shown earlier. So in this method, when you try to access the parameter, you'll see the detail of the parameter. It's really very helpful. And if we go to our class diagram design, here you can also write much more details. If you go to the properties, you will see that there are summary, remarks, and many things. The things that I write in short in the code, you could write it from here as well. And finally, do not use inheritance where you don't need it, because I have seen many developers, many hardcore developers who really do overuse their inheritance, and the system becomes inflexible. So keep in mind that where I use the inheritance, that where I was copying the data and where I really need to make the code more dry, and think of the inheritance as logic. So if you have any logic to make the code inheritance or use the inheritance, do it. But if you don't have any logic, don't do it. And don't try to make all the solution as a strategy pattern, or try to solve all the problems with modular approach. These all solutions are for specific purpose. Unless you need it, don't use it. But always try to organize your code with classes and regions. It is much more readable and better. And if you have any questions, mail me. So thank you for watching this video and session. And to mail me, mail on this address, Alim Ul Karim at developersorganism.com. And you guys can Google me and find my blog. I have a blog, and I'm from Developers Organism. We make products for developers, and we're very creative to have 8 to 5 time. We work remotely, so you can join us, and you can find us at Facebook. Our site is currently under construction. It will be done very soon. So if you really want to join our project, you have to see the first intro video where we have given the email address for joining the project. And that's it. Thank you.